Most of the engineers deal very well with technical stuff. They're really good at this and they become better during the years. But as you grow in all of these roles, you need to impact a large number of people, large parts of organization. And you cannot do this only by coding. We should always learn intentionally. Of course, the best learning is doing. My boss once said to me, like, you become good engineer from 9 to 5 and you become great engineer after 5. Extra time used to practice something is always worth it, in my opinion. What is great software design? This means that we should start always simple. We should not start like with some big fancy architectures and big fancy project structures and such stuff. Multitasking is a myth. It is the biggest productivity killer. Many people get it wrong. Like they try to work on multiple things in the same time and to context switch. This is just a killer of productivity. So to be productive, you must focus on one thing. People who don't have goals don't get so far away. So you need to have some kind of a goals to get to software.
Hello guys, welcome back to another new episode of the Tech Lead Journal podcast. I'm very excited today to have Dr. Milan Milanović today. So for some of you, maybe you have known him by following his newsletter, a very popular newsletter, Tech World with Milan. You might also find him on LinkedIn with a lot of number of followers. So Milan is a very experienced engineering leader. He's now a CTO and also a scholar, published a lot of research. And he's also a coach at the same time. So I'm really looking forward to this conversation. So hopefully we can learn a lot of things, how to become a better engineer or great engineer in summary, right? So Dr. Milan, thank you so much for this time. Welcome to the show.
Thank you, Henry, for the invitation. I'm following you for like a few years, your work. So I'm very honored to be a part of this journey.
Right. Thanks for that. So Dr. Milan, I always love to ask my guests first to maybe tell us a little bit more about yourself, maybe in particular your highlights or turning points that we all can learn from that.
Yes, like I have like more than 10, 20 years of experience, but I would say my experience came much before that because my dad was also a software developer for more than 40 years. So from my early days, I recalled all the things regarding software development and all those stuffs were always all over the place in my house. So when I started to study, of course, that was a natural path because from time to time, I really was intrigued what is like inside, what is happening. It sounded to me like some really creative stuff are going inside. And I started to study and then finished my high school and faculty and then started to work in the industry. But in the same time, while I was started to work in the industry, I continued my work on university because I also liked that work. And I was undecisive in that point of time, should I stay in the research or should I go in industry? So I choose both, which is very rare. Usually people select only one of those, but I tried to stay on both tracks. It was not easy, but I stayed on both tracks. So I made my PhD at University of Belgrade at the Computer Science and Artificial Intelligence department. But in the same time, I worked as a software engineer for one of the biggest company in Serbia. After that, I moved to some like middle-sized Swiss German company where I worked for 5 years. In the meantime, I also worked a lot as a freelancer for some projects, which also helped me a lot to develop some skills that I could not maybe in my primary job. Then, like 2 years ago, I moved to this US startup where I work as a CTO and where we work on one side kind of a product for transportation industry. So, like in these 20 years, I worked in really big enterprise companies with more than 30,000 employees. I worked in middle kind of sized companies, and now I work in startup where there is like 30 people only. So I really saw everything, I would say, from that point of view, how big companies work, how small companies work, how things. So I really learned a lot. And as you said, a few years ago, I started to write about this on different social networks and different channels like my newsletter and other. Why? Because I think during my PhD studies, I learned to write. I learned to research stuff. And then I used all of these skills later to transfer my knowledge to more and more people. First inside my company, I did this inside my company primarily. Then from one point of time, I started to work and write externally also. And I saw that like, okay, people I like this. There's a lot of traction happening. And somehow from that point, things just went on and on.
Wow, thank you so much for sharing your story, right? So I think it's really inspiring. So you have done a lot, you have seen a lot, I guess. And I think in particular, when you mentioned that you tried to stay in both the academic part and also the industry part, I think that's pretty rare for sure. Typically, like you said, like people will just choose one side or maybe juggle from one and then change to the other. But to stay on both sides, I think is really, really commendable, right? So you have done a lot of research in your journey, right, in your career. I think today's topic will try to narrow it down to talking about how to become a much better engineer or a great engineer, right? So I know you have published a couple of research and maybe newsletter as well, right, on how someone can become a greater engineer. So maybe let's start from there. In your point of view, what do you think are the attributes that we should hone in order to become a much better engineer?
Yes, exactly. What I saw from my work when I worked as a software engineer and later as a team lead and a mentor, and also when I was mentored by some other people who were like really top performers in their area, I found some characteristics of those people which I use later also and try to follow the similar path. The first thing was like you need to master like one or few programming languages in depth. So you need to have some kind of a core expertise. And besides this, you need to be like very good in all of those primary engineering concepts like algorithms, data structure, system design, patterns, similar stuff, which are here like some kind of a base. You need that base to grow because everything stands on this base in this industry. And of course, after this, the next thing that I found, which is really important, is that you understand the whole software development life cycle. So from requirements to deployments. And to become, especially if we are talking about full stack engineers, engineer that we call like T-shaped engineer, there's some kind of variations of these shapes, but like the most basic ones, T-shape that you like that you are good in whole the software development life cycle, like from requirements phase, front-end engineering, back-end engineering, and different. But you are really, really good and have deep expertise and at least one field. It can be, of course, more fields, but at least one field. And then, especially for product companies and for startups like we are, you need to have like this, I call it a product mindset or to be like product minded in general. What this means? This means that you really try to understand whys from the customer side, like from client side, and to follow this path to implementation and later to running all of this stuff live. Not like to be just on the implementation side of things, but really to be involved in all of these parts of software development lifecycle and to really understand the customer, what is going on, why are we following this direction, and really to be in the place that will improve our product. Other group of skills are, I call them, maybe some people call them soft skills, but I would say those are like more communication and prioritization skills. And there is a bunch of skills there which are very, very much important, especially for some engineers to become senior lead engineer, staff level, and etc. And those include, like, of course, communication, all of different kinds of communication, from written emails, public speaking, different. Then critical thinking, understanding biases, understanding different mental models, all of this stuff related to soft skills. Of course, dealing with people, working with people, mentoring them, all of these kinds of skills, which are not technical, but very, very much important for one serious engineer to grow.
Yeah, thank you so much for outlining all these different attributes, right? So maybe just to recap a little bit, you mentioned at the beginning that someone needs to master like one or few programming languages. That's like the core skills. Pick any language, maybe the one that you use at work, right? And try to be good at them. And also don't forget about the base, right? Some of the fundamentals like algorithm, data structure, design patterns, maybe object-oriented programming, functional programming, and things like that, because that's gonna be the one who can propel you even further. The base on foundation in computer science mostly stay the same, I would say, but of course there are many frameworks and maybe flavors of how you implement something that change. And after that, you talk about being product minded, right? So try to understand the customers, also understand SDLC, and the last thing is about soft skills. So maybe from your experience in your career, right, seeing a lot of engineers, where do you think that most engineers actually are lacking?
Most is in this part of these soft skills. So most of the engineers deal very well with technical stuff. They're really good at this and they become better during the years. But in all of this, like I would say beyond the coding stuff, the things lack. And as you go more senior, these stuff are more important than technical stuff. Why? Because the technical stuff, with knowledge of programming languages and all of these things, there is a limit of knowledge. I mean, I would say using which is good enough for you to know, because after this point there is something called law of diminishing returns that just it's not need to go further and deeper in this. Or if you are like some kind of a mentor or tutor on this language or big technology, then okay. But for a general software engineer, it's good enough to be on that level. But all of these skills, other skills, as I mentioned, need to be grown because you need to impact as you grow in all of these roles. You need to impact a large number of people, large parts of organization, and you cannot do this only by coding. I mean, it's not possible because there is many people coding. You cannot sit now and write something, something that never is like seen in this world and that will solve all our problems. So you need to create some kind of a leverage and bring other people on the surface and enable them to produce like better and better results. And all of these things you can do only if you have all of these skills set.
Yeah, I tend to agree from my experience as well, looking at the different engineers, at least from my career, right? So I think soft skills, maybe the people dealing with people part, right? I think seems to be we need a lot more, I don't know, coaching or maybe even like practice in order to become better. And especially like you mentioned, as we grow more senior and even becoming a engineering leader, like VP or CTO or engineering manager, these soft skills tend to be much more important rather than technical skills, right? So maybe soft skills is definitely one area, right? The other part that you mentioned is about learning new technologies because these days, I mean, we can tell that there are so many advancements, AI ML is probably one of the latest, but before that, there are plenty, right? So what is your advice for engineers to deal with the rapid change of technology? How should we keep up? How should we update ourselves? Maybe a little bit of tips, maybe from your point of view as well.
Yes, I think we should always learn intentionally. So when we have something in front of us, like when I say in front of us, this is like something we will need like in 3 to 6 months. We should start and research about this and start learning it. Of course, the best learning is doing. So there is no other way. Everything else, there is this learning pyramid. I published this in my newsletter, where the retention of learning from different methods differs. So the best retention is by doing. So when you take a look at some kind of a tutorial and you do really something, this will retain in your head. For all the other things, like reading books, learning from conferences, other stuff are good because you broad your vision with this. You know what's there, so you know how to tackle maybe some things in the future. There is one thing called circle of competencies. I also wrote recently about this, where in the center you have the circle of your competence. So these are things that you know, your skills, like your technical skills, let's say. There is other layer outside. There are skills that you know that you don't know. So, for example, you know there is a React framework, but you don't know it. So you can easily start and learn it. But there is a much outer layer. There are things that you don't know that you don't know, or some people call them unknown unknowns. And this is the area where you can grow the most. And what are those things? Those things are, for example, some of these skills I mentioned to you, which are usually not visible, not clearly visible to developers, and also other skills like product knowledge skills, like marketing skills, sales skills, all other things which we don't have in our mind when we are doing this job. Of course, there are ways how we can go that. For example, one fast track is to find a mentor who will say to you like, okay, there is this thing, you don't have this at all in your mind, but there is this thing, go and learn it. So this is one way. There are other ways, of course, how to go to this path, because when you go to this path and you find some things that you never thought that they exist, this will bring you the most growth in your career and life, of course.
Yeah, I saw your newsletter, right? You published a lot of articles and you went really deep into the topics for every of the articles, right? So I think this is also probably coming back to your background as a researcher, a scholar, right? So you did a lot of research. So for people who want to become an expert in a particular topic or domain, or maybe even like a particular technology, right? How do you recommend us to become much, much better in the domain, or an expert maybe even one day?
Yes, there are a few ways, like a few ways how we can do this, but I like to do this in a structured way. Why? Because when you do things in a structured way, it's easier to follow. For me, it was always easy to be a scholar because you have the path that you just need to go to this path. If you don't have a path, it's really hard to follow something. This is good for creative stuff, but if you have some job to do, it's much better to have like a defined path where to go. There are two frameworks that can be used in this area and in learning new stuff. One framework is called 4 stages of competence, and this means that when we start to learn something, we go through these 4 stages. So the first stage is unconscious competence. This is, as I said, those are like those unknowns. So we don't know that some things exist at all. So maybe they exist. We don't have any knowledge in this. And so at this stage, we need to find them out first. So as I said, there are ways how to find those stuff. Then there is conscious incompetence. Then is where the real learning begins. At this stage, you know that there is this thing, but I don't know that I'm not like knowledgeable about this. But I know now. Okay, I know that this thing exists. The next thing is to take and learn this stuff. Okay, I now take it. I go to some tutorials, I read some books, I talk to some people, and now I'm at the level of conscious competence. So now I have some skills to work with it. I may be really good in some parts I'm not good. So it's some kind of a third level. But to be an expert, we need to go further on the fourth level. It's called unconscious competence. This is where the skill become natural to you, or like where the skill go in the unconscious part of the mind, like when you drive the bicycle. So you don't think when you drive the bicycle like, okay, I need to move this leg or this hand. So this is the same with all other skills that we can develop, and we want our knowledge about the stuff to be at this level. And when they are at this level, we are then can be called an expert because we don't need to think about this. What are some examples of it? Like when you learn Git, when you know Git so well, you don't need like any checklist. You don't need to remember yourself. Oh, how I need to do like branching or rebasing. So this is all natural to you. And how we went to this level is just with a massive amount of practice. So a massive amount of practice, many hours. There is this book Outliers from Malcolm Gladwell, where he said to be an expert in some field, you need to work 10,000 hours in some area. So it's 5 years of full-time job, let's say. And he gave also an example of with violinists, when he showed that the best violinists are those who practice the most. And I believe that this is the same probably with software engineers. Then there is another framework called Bloom's taxonomy, which is a bit more granular. So this 4 stages of competence describe how we should go in which kind of a direction. But if we have concrete thing that we want to learn, we can use this Bloom taxonomy because it gives us a nice structure how we should do this. And there's like 6 levels of knowledge. For example, I will give an example of clean code. For example, learning clean code with this Bloom taxonomy. The first level is remembering. So we just at the first level we just learn about clean code. So we just read about this, we learn some kind of principles, and okay, we kind of get some things from this. Then the next level is understanding. At this level, we need to prove understanding of this material by explaining these concepts in our own words to some other people. There is also one Feynman technique for learning, which also uses the similar concept, but famous physics professor Richard Feynman. When you can like explain in simple words some concepts to someone other, you understand it very well. And now on the third level is applying. So now let's apply these things. So now you need to apply all of these like clean on concepts. You have understanding of this. You can then now use it in everyday work. You can really apply it. Then on the next level, you have analyzing. Now you can understand better when you take a look at the code. Is this code good? Are there any issues with this? Like, okay, this is clean code, this is not clean code. Okay, I need to like refine this variable name. I need to extract this method. So you are now really, in the flow. Then the next level is evaluating. At this level, you now make judgments about different approaches. And this is the level where I see that most people don't go. Because most people are on the previous level analyzing. They learn clean code, they push it everywhere. But at evaluating level is where you really try to see maybe here I didn't need clean code at all because performance are much better. Clean code is not performance, but here I need performances, or maybe I need to do something third here. I will not just now apply these principles wherever I see them. And then, of course, there is the final level creating where you now are able to create new ideas, new concepts, like new strategies, how to work with this. So this is really the final level of knowledge on this area. In front-end development, it will be like creating of a new framework or a new library or similar. So something like this. Of course, only if it's needed.
Yeah, maybe for clean code, it will be like the cleaner code. So I think
Exactly.
these two frameworks are definitely great, right? So like you mentioned, right, sometimes we need a framework or kind of like a path, a direction, right, to aim for and kind of like follow in order to become an expert. So I think definitely one thing that you mentioned, it takes a lot of practice, right? Or maybe like Malcolm Gladwell said, 10,000 hours. So do you think for engineers, if they want to become great, maybe for a particular topic, maybe like clean code, does it mean that we have to always do programming, inside of working hours and outside of working hours? Or do you think becoming an expert also requires a multitude of different activities?
My boss once said to me, like, you become good engineer from 9 to 5, and you become great engineer after 5. So, and I somehow understood it well because it doesn't mean like you should do overtime, but like after work hours, you can like read some books. I'm a big fan of books. You probably noticed it, and you can do something extra to learn. And with this, you reduce this time to get to these 10,000 hours, then you don't need maybe 5 years, you will get it in 3 or 4 years to this level. So I strongly believe that there is something. And even though there are many talented people and people who works a lot, I found in my career that people who work and push these extra hours, they were really good in their job. And there is something behind this. I mean, I don't want to be like that. I support like some kind of hustle culture and overtime work, but I think when you do extra, you have this in football. You probably heard that like Ronaldo and all other guys, when the regular training is finished, they go and practice 2 more hours. I mean, this is in every field. This is not only in our field. So extra time used to practice something is always worth it, in my opinion.
Yeah, I think some of the famous sportsmen that I know, like Cristiano Ronaldo, Kobe Bryant, right? They always practice like come early and finish late, right?
Exactly.
So I think, yeah, it's not an endorsement to do like hustling work, like you said, right? But I think to become an expert really requires a lot more dedicated effort and intentional learning, right? Not just doing it 9 to 5 or something like that. So
And
another thing
focus.
that, Yeah. So another thing that is quite common when in technology, right? Like they think they will never become an expert. So some people say it imposter syndrome. So they always feel that they are consciously incompetent. So maybe any kind of tips from you how we as technologists or engineers overcome this imposter syndrome, right? Feeling that we're never gonna be an expert enough.
Exactly. This imposter syndrome is something that is especially present in our field. Why? Because it is so large and there are so many topics. And if you are like expert in one field, tomorrow you can be in another company, in some other project or team where there are some things that you don't know. And then you are immediately hit by this imposter syndrome, and you will tell yourself like, okay, I'm really not good. I'm not expert. I mean, and this is a pendulum that goes from imposter syndrome to Dunning-Kruger effect, which is constantly shifting from left to right, because you now are bad at this, you learn it, and then you say, okay, now I'm really good, I'm really great in this, and then tomorrow you can again feel like, maybe I'm still not good. So I just want to say that we in this industry need to be aware of this effect. This is the first thing I wrote about this multiple times. We need to be aware of this because when things happens, we self-reflect on this. Okay, now I understand why is this happening. Okay, I'm not bad. This is happening because there's so many things, so many languages, frameworks, things are going on every day. So I cannot know everything. That's normal. Just normal. What we can do, I mean, we can say to ourselves this, like, okay, this is normal, and then like go bit by bit and start try to learn all of these things properly. So there is no magic potion like that we can drink and finish it. But the thing is that we need to really, really be deliberate about these things and how we tackle all of new stuff. There is a wording, be brave to suck at something new. And I really believe strongly in this. I mean, especially where someone with a lot of seniority and experience, because we need to just adopt the growth mindset. Okay, I know some things, but there are much more. You remember this circle of competencies. There are much more things I'm not expert. I don't know at all that they exist. This is just a natural thing. And when we accept this in this way, imposter syndrome becomes much better in our lives. Yeah.
Yeah, thanks for the tips, right? I think in the tech world, I don't think anyone could catch up with everything, all the advancements that happen. Plus, they are just too rapid, right? So maybe one day you can catch up, but almost immediately you will be behind again, right? So I think thanks for the tips.
Exactly.
Nevertheless, right, I think in one of your article as well, you mentioned in order for us to become a better engineers, right, we should also note things that tend not to change, right? Your title is about learning things that don't change. So tell us, why is this important for engineers, learning things that don't change? And how and what are topics that we should learn that tend not to change in engineering?
Yes, like I have like more than 20 years experience in this field, and I saw stuff that were here and they are not visible. Let me mention few like flash, silver light, different kinds of technology that were here, but there are some things that are here from 60s, like SQL. It's like for 70, 80 years here. So, and it will probably stay much more. And there is some effect called Lindy effect, which explain us why some technologies are still with us and why some disappeared from the market and from our lives. And this Lindy effect proposes that the longer a period of something has survived to exist or to be used, it's longer it remain life expectancy like for this thing or this technology. This tells me that developers will still use like SQL when I am retired or like some similar things. And why is this important? I call this like learn the fundamentals and not frameworks. Of course, we need to learn some cutting edge stuff because I mean, people in this industry like to learn. There are some really advantages in some stuff that really make us more productive and to create better output. But learning these fundamentals allow us to understand like these underlying principles and concepts across all of these different frameworks, languages, and enables us to have more flexibility and adaptability when working with new technologies and facing problems. Because when you have this base, it's much easier to understand all of these things. So, what are those fundamentals that we should learn really deep? Like, as I mentioned at the start, the algorithms, data structures, principles, object-oriented programming, design patterns, distributed computing principles, system design, and so, like all of these things that are here for like databases are here for many years, and they will stay for many years. Some other things are here just for a few years or like maybe a decade, then they will just disappear and no one will see it anymore.
Yeah, so I think the Lindy effect is something for us to reflect a lot, right? So just to recap again, the Lindy effect, right? If something stays for quite some time, right, most likely they will stay relevant for a longer time, right? So you mentioned SQL, I think like TCP/IP, HTTP, networking aspects, I think really change, right? And maybe like data structure design pattern, system design, and all that. So I think for those engineers who listen to this, be mindful about this Lindy effect, right? So when you pick on new things to learn, right? Maybe start from the fundamentals rather than the framework. Of course, sometimes in the job you have to master a particular framework simply because that's kind of like expected for the role. But to stay long in the game, in the engineering game, right, you need to master the fundamentals. So I think thanks for highlighting that. So
Exactly. And here I have also one important things to say. I think we should try to be general software engineers. Why? I often see, you probably saw also, like, I'm a React developer. I am Java developer. I mean, okay, this is specialization, some kind of. But I think we as software engineers should be generalists. So, okay, I'm software engineer. I'm primarily problem solver. So I solve problems. And in solving these problems, I use some tools. Those tools are Java, React, just you can put anything inside. Just be flexible with all of these things. We also see this trend in big fund companies, big tech, and other companies where they just are asking for general software engineers that can work with really different, diverse aspects of technologies and tools, because those are tools. I mean, if you know all of these concepts and all of these foundations, you will learn any tool very fast. But if you are just a tool developer, like I'm just a React developer, you are just then really specialist in this field, and it's very unflexible for you, your career, but also for your employer tomorrow to put you in some kind of other positions and roles and to grow maybe even further.
yeah, so I think that's a very good tips, good call out, right? So don't take any particular language, framework, whatever that is, as your identity as well, right? But just like you mentioned, I'm a React developer, right? So I think I'm a front end developer, probably is much better rather than a particular framework developer, right? So I think this thing is definitely very, very important, right? The other aspect of a good engineer is definitely producing a good quality output and deliverables, right? It could be the code, it could be the non-functional attributes part, or you bracket it together as a high quality engineering. So maybe from your view and also in your career experience, right, what stands out for engineers who can actually produce high quality engineering?
Yes. As I mentioned a bit earlier, the first thing is like this customer centricity. I think this is very important. As I said, those are people who I like to call product minded engineers. So those are people who really try to understand why are we doing this? And why is this important? Because when they understand this, they can ask better questions, they can challenge some stuff, they can lead this process much better than those who are just waiting for a task to be defined, the user story, and then just to implement it. Because I mean, AI is much, much better now. In a few years, I will just implement the things from the user story, probably, or most of it. So we as problem solvers need to be more on this left side of the line than on this right side, only like implementers. Then I think that high quality work as a software engineer include good software design. I wrote a lot about this, so I will just try to explain this shortly. What is great software design? This means that we should start always simple. We should not start like with some big fancy architectures and big fancy project structures and such stuff. Why? Because there is something called project paradox. It means that the number of essential decisions we need to make at the line of the project decreases while we work on the project. And we need to make all of these big decisions at the start And at the start of the project, we have the least knowledge about how project will go, how it will be structured, how many users, and that, etc., etc. So we want to decrease number of important decisions at the start and to put that later in this timeline working on the project. So I always say good quality is to start simple and then develop this further. What this means? This means like we can start with modular monolith architecture at the start, and then if we need it, like if we grow so much with many users and we need more scalability, we can always transform this architecture to microservices or some event-driven architecture and similar. Then, of course, there is a code level where we need to have really good quality. What is good quality? This is also a wide subject, but I like this definition from Ken Beck, who has said like good code passes tests, reveal intention, have no duplication, and have fewest elements to do what it needs to do. On the other side, what is bad code is really hard to say, but we have these code smells. So we need to learn like these code smells to know, okay, this is not good, this is good. So we need to have these principles in mind, but also to be knowledgeable about all of these different kinds of code smells that can happen in our code. Then we need to be part of the good engineering culture. What this means? This means like we have good psychological safety to experiment and fail. If we are stuck, for example, for 2 hours, we can ask someone to help us. That we do code reviews, pair programming, that we have possibility to have these stretch roles, like to be on this line of T-shaped developer, to constantly learn new stuff, to have like mentors, coaches, and in the end, you work in a happy team. So the team where developers are happy and like to work on the thing. Also, this includes good engineering practices that are present there. Like you have source control, you have tests on all critical levels, like on the test pyramid. You use properly patterns where they are needed, like you use TDD, you are checking for YAGNI, dry keys principles, solid principles. You have automatic code analysis, linters, all of the stuff inside. You document all of the important decisions in close to the code also. And this is really, really one important part because this is our surrounding that can make us to produce high quality work. Then, of course, we need to have this quality first mindset where we need to cover everything and to have all of these proper kinds of tests and also including probably QA roles and all other roles, depending on, of course, on the structure of the project, where we want to produce only high quality software without bugs. We also use in our company like a zero bug policy. We don't have any bugs in backlog. Why? Because your software can be really great. Users don't like bugs to see. When they see bugs, they will lose confidence at some level to your software. So this is something we don't want to see in high quality software. We don't want to see bugs. So I think every extra effort there is really good to have.
Yeah, so I think there are many things that you mentioned just now, right? I'll try to mention a couple again just to recap, right? The first is most importantly, customer centricity, right? So always put the customers in mind, try to understand the requirements, challenge the assumptions and things like that, right? The first thing is to make the customer or user happy. Second thing is about the software design, right? Use a great software design. You mentioned a couple of things just now as well. Good code quality. So I think I like the one that you mentioned about Ken Beck's principle, right? So pass the test, reveal intention, fewer duplicates and things like that. And good engineering culture and principles, which probably also relies a lot on the engineering leaders and the culture within the team and the company, right? So not solely responsible by the engineer. And then the quality first mindset, which is probably is something that we all need to be conscious about, right? Because sometimes due to pressure from externals, we tend to kind of like relax the quality in order to deliver faster. So definitely these are good high quality engineering for people who would like to learn more. I mean, do check out the articles. The last thing about great engineer that I'd like to talk to you about, which I think you are also like seem to have a lot of expertise, right, is to become a more productive engineer. So one thing that I noticed, right, I think great software engineer do not just master a technology part also the customer centricity and all that, but they seem to be able to produce more. So tell us maybe some secrets that you think that makes engineers much more productive than the others.
Exactly. I wrote a lot about productivity, and this is not like because I want to be productivity expert, like much more productivity expert who are famous, but I found that this thing is something that like no one learned us. And during all of my roles, I never had like any session with someone like my boss or my mentor or someone who came and said to me like, okay, now you need to improve this regarding your productivity. Or like, okay, now you need to use this technique, like you now procrastinate, you need to use or try this or try this. No one said to me. I needed to research this by myself, which was hard, There was a lot of trial and errors there. So after using all of these different methods for many years, I think I got it, how they should be used. And I wrote a few times about those. The most important thing maybe is like multitasking. Multitasking is a myth. It is the biggest productivity killer. And I saw this that many people get it wrong. Like they try to work on multiple things in the same time and to context switch. This is just a killer of productivity. So to be productive, you must focus on one thing. So pick one thing, block the time in your calendar, like 2 or 3 hours to work on it, turn off notifications, and work on it in a focus mode. There is a good book by Professor Carl Newman called Deep Work. I recommend everyone to read it because it goes much, much deeper into this deep work. Why we need deep work to be, because we as software engineers need this thing called flow state, to be in flow state. Why? Because we need to work with high concentration levels to solve problems. And to be able to do this, you need to be in this flow state. The only way to be in this flow state is to work in these deep work periods during the day. How I organize my day is usually I move all meetings in the afternoon, so no meetings before 2 o'clock. And then I use this 3-3 method. I use like in the morning. I mean, it depends from different people have different timings, but usually in the morning you have the most energy when you start working. And I use the first 3 hours to tackle the most important thing I need to do today. Then afterwards, I also some 3 shorter tasks, and then afterwards 3 some maintenance activities like sending some emails, some documentation stuff, and then similar. And this is really important. The other thing is prioritization. I recently wrote a mini book on this because there is different levels of prioritization. Now we are talking about personal prioritization of productivity. There is also team prioritization and then leadership prioritization also, but this is some other topic. Regarding the personal prioritization, we can use something like Eisenhower matrix, where we need to understand that not everything which is urgent is important. And why is this important? Because we want to work on non-urgent and important stuff. If you are working on urgent stuff, that's not good, because urgent things should happen from time to time. If you are constantly in urgent mode, something deeper is not good. So you want always to focus on the important but non-urgent stuff. This is where you produce the best results. Of course, if things are not important, not urgent, you just don't do them, but remove them. Then, of course, many developers are big fans of some kind of a personal organization. I needed a lot to figure it out what works for me. And I found this great framework. There is also a book by the author of it called Getting Things Done, GTD framework, which you can also actually use in any like to-do app. There are some apps like Todoist that have already this process integrated. Then you have like a process how you take all new ideas in part. Then you have next actions that you can do any moment. If you need to do this, if you can do this for less than 2 minutes, do it immediately. There is also waiting for column. So if it is something kind of a blocked, then if you have projects that have more than one action, and then someday things that you will do something. And there is this process how you transfer things here. Then there is this second brain concept also. Why it is important? Because all of us take notes, but notes are usually chaotic in most of the people, And I think this is also a really important part. Why? Because some wise people said mind is to have ideas, not to store knowledge inside, like especially unnecessary knowledge. And we want to offload this knowledge into some kind of notebook. And second brain concept, if you have also a book by Tiago Forte here, that enable you really to transfer all of your knowledge into these great notes, and you can then find them really quick, when you need them. Then also, one big topic here is procrastination. Of course, there's always things that we don't like to do. I mean, we cannot always work on things which we are really, really happy to work with. And there is where packings or low have impact. It says that the work expands to fill the time available for completion. What this means, like if I said to you, you have 3 days to complete, and you maybe can complete it in 1 day, you will probably do it for 3 days because you have time, you are given that time. And here we can use some kind of techniques like Pomodoro technique. There are some variants of this technique where you work in 50-minute blocks and etc. As I said, variants, there are some variants where you can work in larger blocks, not to interfere with this flow state we want to achieve. Then, what is also important for personal productivity, on personal perspective, but I think on team perspectives, are these weekly plans, and not daily plans, because day is a short period. Everything can happen in a day, but these weekly plans. So on Monday, I plan to work and finish something. I have a goal to finish something until the end of the week. And then at Friday in the afternoon, after my work, I sit 50 minutes and reflect on this week. What did I do good? What didn't do well good? Why? How I can this improved for the next week? And then when I usually on Sunday evening create a plan for the next week, I then incorporate all of this knowledge from the previous week to improve for the next week. And then with these weekly plans, I clearly know what impact I want to achieve this week, and of course, what I don't want to impact. And this, of course, should be also connected to monthly, yearly goals. I also have a book on setting and achieving goals on this, like short books, 60, 70 pages, because people who don't get goals don't get so far away. So you need to have some kind of a goals to get to somewhere. So this is like in the most shortest explanation of how I see developer productivity in this part.
Wow, I feel like really overloaded, right? All these productivity tips and hacks, right? So you mentioned a lot of good techniques and tips for us to be more productive. Things vary from, like the get things done, Pomodoro technique, Parkinson's law, which I find really, really effective. Sometimes if you just want to make things happen, right, you limit the time because but the time actually will be the factor how someone actually completes the work. Of course, you don't give like a very unrealistic time, but sometimes by giving a much more aggressive timeline, things get done much faster, right? And we all like to
Exactly.
procrastinate as a humans, right? And the other thing
Exactly.
is I find
Deadlines here, are really, really good solution. So adding deadlines to things really good, or time boxing things also works very good.
yeah. And also another thing that I find, like despite so many productivity things that are happening around the world, right, with so many research and maybe people who are following those things, you need to find one that suits you best, right? Because there's no one productivity technique that works best for everyone. So for example,
Yeah.
like sometimes I do want to procrastinate or sometimes I don't follow get things done simply because there are too many things that I need to do in order to get the framework going, right? So I think the key for us here also is to find one that works for us. Don't be afraid to experiment and maybe give it a try. But sometimes, you might find your own productivity hacks that probably you should share to other people as well. So I think that's one thing that I learned throughout my journey. So, Dr. Milan, thank you so much for all the things that you have shared. We have come to the end of our conversation. I have one last question for you, which I'd like to check with you to share what I call the 3 technical leadership wisdom. So, from all the things that you have shared, maybe if you can condense into 3 different advice, what would that be?
Yeah. Before that, I would like, because I'm actually doing a lot of education. I mean, I see this like writing newsletter, writing social networks, because some kind of education. And in our world, there is a lot of like new joiners, newcomers who are just learning. I want like to share one wisdom for them. For all of guys like who will be tomorrow with us or who are maybe today are also working with us, there are two most important things. It's like to learn how to get shit done. So how to finish something. And the other thing is to always try to under-promise and over-deliver. So this is also very important. With these two things, you can be in really, really good position after some times. But regarding some kind of a broader leadership wisdom that we can share, like the first thing is to always try to align technology with business. As we said, like this customer centricity is really good. We want always to try to understand business requirements, and then to decide on technology. What is so many times that we just like jump on some hot fancy technology. I'm in the club of those guys who said like choose boring technology. And okay, we need to be updated on latest trends. We need to know what's happening. Maybe there is something really new and good that we can use and that will empower us and make us efficient. But always try to critically think about them. Do we really need this, or maybe we can really we can work with the things that we already have? Is this the effect that we want to achieve? The other important lesson is maybe, I mean, the people are the most important part, as we said, of everything, not technology. So as a tech leader, our primary responsibility is to enable our team members to excel, to be that leverage. So try to always empower them in the right way, to delegate responsibilities and to trust them, to allow them to work in a psychological safe way, and that they can like experiment and fail, and they like are happy with the place where they work. And what is here important, there is some book by Daniel Pink called Drive, which said like people need to have autonomy, mastery, and purpose to be really satisfied with their job. So autonomy, don't micromanage them. Purpose, they need to have some kind of a high purpose. And this is what we see in product companies. Product companies have really good vision and some purpose we want to achieve. And when people see that they are really part of that purpose, they feel much, much more motivated. And of course, mastery. People in our industry like to learn stuff, like to be expert and good in this stuff. And just we want to enable them. We can enable them in different ways how they can learn stuff. Send them to conferences, buy them books, enable them to learn, give them stretch roles. There are many, many ways how we can do this. And the last thing is, I want to emphasize, we need to like enable this culture of continuous learning. So our technology evolves daily. So we need to be able to track those trends and to like develop necessary skills where they are needed. We cannot be like blind to all of this stuff. Of course, as we said, we need to be careful not to jump on things, but we want to enable our people to have the touch with the latest technology and that we know how this maybe can help us tomorrow.
Wow. So I think the last one really important for all the leaders, right? The managers who listen to this podcast, right? So definitely great things to be conscious about, right? So enable your people, give psychological safety for them to experiment, allow them to learn as well, right? So I think really, really great. So for people who would like to follow you or maybe check out your work, right, and stuff, maybe is there a place that you would recommend them to find you online?
Exactly. They can check my newsletter, Tech World with Milan newsletter. I also write on social networks and some other places, but I tend to move all of the like stuff that have the most traction and which is the most quality to my newsletter currently, which is free to read, so anyone can subscribe if interested in all this and some other topics.
Right. So I'll put it in the show notes as well. So Dr. Milan, thank you so much for sharing all these things. I hope this conversation can inspire a lot of engineers to become better at their craft, to become a better and productive engineer as well, and produce high quality engineering at the end of the day, right? So thank you so much for this sharing, Dr. Milan.
Thank you for the invitation, and I also hope that this will impact some people to become better in their careers and lives.